Today's topic is moment of inertia. First of all, you should know what is moment of inertia and how it is important, how it is useful in studying dynamics of a particle. So, all of you know what is inertia. Law of inertia given by Newton, that is inability of a body to change its state. If you have a body and if you want to move it, you have to apply a force on it. So that force, any arbitrary force will not do. That force must be proportional to the mass of the body. If you have a big body, you have to apply a big force. So that is why to change the state, force is required and that force is proportional to mass. Therefore, the mass of a body is the measure of inertia in linear motion. This is all. You know, it has been taught in physics from high school, intermediate, everywhere. But we are interested in finding out the rotational motion. This is valid for linear motion. It may be linear motion of 1 dimension, 2 dimension, 3 dimension. But if it is a case of rotational motion, what happens? A quantity that measures the inertia of rotational motion, that is called moment of inertia. Which quantity? That measures the inertia of rotational motion. That quantity can be in 2D, that can be in 3D. Okay? So, moment of inertia plays the same role as mass plays in linear motion. In rotational motion, we need moment of inertia. So, I think the meaning of moment of inertia is clear. It consists of two terms. One is moment, another is inertia. So, you have completely understood the inertia. Now let us try to understand the moment. Moment is also known to you. What is moment? If you have a body, suppose here a force is acting on a body and about this point you have to calculate the moment of this force. So you know what you will do? You will drop a perpendicular on it and the moment will be force into P, and of course it has two signs, plus and minus. If this force tries to rotate the body in anti-clockwise direction, you take moment positive. If it tries to rotate body in clockwise direction, you take moment as negative. So these are the basic concepts behind moment of inertia. Now you have understood what is moment and what is inertia. Now let us define the moment of inertia. You know, every body consisted of number of mass particles. So if you have a body, I am taking the figure of 2 dimension. Of course it will be extended for 3D as well. So if you have a mass particle and you want to calculate its moment of inertia about OX. Okay. So what you have to do? You know this mass particle consisted of number of masses M1, M2, M3 and so on. Every body consisted of number of mass particles. So to calculate moment of inertia, we we divide the body into small tiny pieces of masses. Okay. Then we calculate the moment of inertia of each and every mass about the given axis. Suppose our axis is OX, then moment of inertia about OX of the body will be summation of M1 R square. So what you will do? You will consider the perpendicular distance. If this distance is R, then the first term will be M1 R1 square. Then second term will be M2 R2 square plus M3 R3 square and so on. So that will be the moment of inertia. So it is written as summation of M R square. So what you have to do? You have to find the perpendicular length from the axis of that mass particle and then mass particle into this distance squared. That gives you the moment of inertia of this body about x-axis. Okay. Now this is also written as capital M K square. Capital M K square. Now if your body has coordinates x1, y1, x2, y2, these mass particles have this much of coordinates, then this perpendicular distance r1 will become y1. So it will be equivalent to summation m y square, and that is termed as capital M K square. What is capital M? The total mass of the body and what is K? K is radius of gyration. This is a new term. It is radius of gyration of the body about x-axis, about OX. I hope this term is clear. Now, if you want to find the moment of inertia about OY, then what will happen? Then you have to measure the distances from this axis, perpendicular distances, and you can observe the perpendicular distance will be for M1 it is x1, for M2 it is x2, so it will be summation of mx square. So that will be the moment of inertia of the body about OY. Then there is one more term, that is product of inertia. Product of inertia about OX and OY. So what it will be? It will be summation of M, X, Y. Okay. So if you are dealing with 2 dimension, then only these 3 terms will do. If you are dealing with 1 dimension, only 1 term will do, summation M R square. Now mind one thing, that this body consisted of number of mass particles, and for each mass particle the distance is different. So you cannot take distance outside the summation. Is this point clear? You cannot take distance out of the summation convention. For example, here you can't say this is equal to capital M into X square. No. This is the summation of mass into perpendicular distance square for each and every particle which is forming a given body. So this is the definition in 2 dimension, because you have to find the number of cases, you have to work out number of cases where it will be required to find the moments and products of inertia of a given body. That given body can be of a regular shape, that can be of irregular shape. Everywhere you have to find if the moment of inertia is required about x-axis, it will be summation my square. If moment of inertia is required about y-axis, it will be summation mx square, and the product of inertia will be summation mxy. Now, if it is a case of 3D, what will happen? Then each particle will have coordinates x1, y1, z1, x2, y2, z2, and so on. This is your z-axis. Then moment of inertia about OX will be summation of m y square plus z square, because that will be the perpendicular distance square, and this is termed as capital A. So the value of capital A is summation m y square plus z square, that is the moment of inertia of this body about OX. Similarly, moment of inertia about OY, it is denoted by capital B, and it will be summation m. Now the distance, perpendicular distance from y-axis, you know it will be x square plus z square. And C, summation m. This is about z-axis, so you will be getting x square plus y square. After that, you can define 3 more terms, D, E, and F. What are these? These are the products of inertia about x-axis. Product about x-axis means summation m yz. Product about y-axis means summation m xz, and F means summation m x y. So these are the terms you will be using in the exercise which follows, which you have to do. So that's all for today. We'll continue hopefully for the next term. In the next video, I will be doing some simple cases. I will be solving the moment of inertia of some simple cases, and after that some complicated cases. That's all for today. Thank you very much.